Morning, sound good. Uh, first of all, I hope your history went well today. I know that was, I'm sure it was tough, but it seemed like you guys were doing really well yesterday. So I really hope it was good news today. We're going to jump right into the notes today. This is our fourth lesson in Unit 3, distributing with rational coefficients. Let me share my screen. All right. So we're just going to start with the title. Distributing with rational coefficients. Again, that is U3, L4. This is 7th math. And today is 11/5/20. So first of all, when we're just talking about distributing rational coefficients, we're talking about distributing with both negatives and like fractions or decimals. We'll mostly be using fractions today, I think. And usually we use fractions. We'll also go over how we can check whether we've actually distributed and really just simplify any kind of expression correctly. And we'll see a proof of why distributing works, or y equals the same thing. We're gonna actually start with that proof, and we're gonna use distributive. We're gonna distribute again here. Excuse me. We're gonna distribute with a rational coefficient with -2. We have -2 times 6 minus 4. I'm gonna solve it two different ways. I'm gonna set up two errors. I'm gonna again just write the original. I always like having the original expression or equation if we're solving equations directly above what I'm solving. It really helps me keep track of everything, and I think you guys should do that too. Now, when you have all like terms, and like 6 and 4 are like terms, and you can just combine them, you can always solve this without distributing. You can solve it just by doing what's inside parentheses. 6 minus 4 is 2, so we use this with -2 times 2. -2 times 2 is -4. All right, great. So when we distribute here and solve it, we should get the same answer. Remember, though, we have to be very, very careful when we're distributing with negative coefficients. Because a lot of times, the biggest mistake that we're going to make, we're going to forget to distribute this negative coefficient to the second term. You have to distribute it to both terms. That's why after we draw our arrows, and never forget to draw your arrows, after we draw our arrows, I like to write out the multiplication before actually showing the product. So -2 times 6 minus -2 times 4. -2 times 6 is -12 minus -2 times 4 is -8. Remember, a negative times a positive is a negative, and 2 times 4 is 8, 2 times 6 is 12. Here, though, remember, when we are subtracting any number, it's the same as adding its opposite. So subtracting a negative is the same as adding a positive. Anytime really you see this minus minus, you should immediately just make it plus plus immediately. So we have -12 plus 8, which -12 plus 8 would be -4. Oh, look, they do match. So again, you have to remember to distribute, excuse me, you have to remember to distribute this -2 to the second term. A lot of people will get plus -8 here, and that'll give you -20, which would not be the same thing as -4. So be careful there. However, we can see why this distributive property is important if we look at a very similar expression, or one that has a variable. So in that case, I'm still going to have -2. So this time it's going to be times 6 minus 4x. Now, if we think about solving it this way, by doing what's inside parentheses first, well, these aren't like terms. We can't combine them. You can't actually do what's inside parentheses. You don't know what that's going to equal. Oh, I forgot to write my expression on top like I always like to start with. It's easy to make mistakes. Always try and go back and fix them if you can. Again, in this case, you can't combine like terms. You don't know what that equals. So you don't know what the multiplication is going to equal. So you can't do it this way, unfortunately. So you have to use the distributive property. So again, I'm going to write the original expression. Part of the reason why I need to write the original expression, I need to be able to draw my arrows. So I draw the first term to the second term. Again, write out the multiplication first. -2 times 6 minus, we're just bringing down that operation. Now, what I'm multiplying in, -2. Remember, put parentheses in front of it because it's following operation. And then 4x. In this case, -2 times 6 is -12 minus -2 times 4x is -8x. But look again, we have two negatives. Subtracting a negative is the same as adding a positive. But you see two negatives, so I'm not going to get positive. And that kind of even works for multiplying or dividing. Remember, a negative times a negative is a positive. And a negative divided by a negative is a positive. And subtracting a negative is adding a positive. So very similar. So in this case, it means that we end up with -12 plus 8x. All right, awesome. So we think that we've done this correctly, but partially because I haven't done this a lot and I know it's easy to make a mistake here, I really want to be able to check, how do I know whether I'm right or not? How do I make fully sure that I know I'm right here? And we can always do this, whether we're distributing or kind of simplifying any expression. If you have a variable, you can always check by substituting. So we're going to put that note in first, and then we're going to check this by substituting. So always check if you simplified correctly by substituting the same value. And usually we're going to want to choose an easy value for substituting. It can't be 1. Oh, I almost was going to go off the page there. She's already aware of that. You can't substitute 1 because if there's cases where it could be you make a mistake, but 1 is going to get you the same answer anyway. 1 times anything is itself. So a lot of times, if you have 1 in that, if you substitute in 1, it's not going to really work. But if we substitute something like 2 or 3, that would work. That'd be really easy. You want to choose easy numbers for yourself. Sometimes if we're substituting in and there's a coefficient that's a fraction, it's good to choose a number that you can cancel easily, that can be divided by whatever's on the bottom. Or whatever's on the bottom can be divided. Oh yeah, it can be divided by whatever's on the bottom. So like if it's like 1/9 times x, substitute in 9, because 9 divided by 9 is 1. That's an easy answer. So usually we try to choose easy numbers, whether that's because they're small numbers or because they cancel easily. Let's finish writing this actual sentence. Always check if you simplify correctly by substituting the same value into both the original expression I'm going to underline that, and the simplified expression. And by the original expression, I mean the very first thing that was given to you. Any change you make, going from this step to this step, you can make a mistake. So you want to make sure that you're substituting into this expression, not into any other one. This one and then the last one. And the way that we write this, and the way that I'm going to be expecting to see it in your work, is first of all, Sorry, I'm a laptop in the way over here. First of all, I like to just put like check kind of diagonally. It kind of makes it stand out for me, and I know this will let you my check. Now, when we're talking about check, again, we want to choose an easy value for x. So let's just choose the easiest value besides 1, 2. So the let statement. A lot of times the let statement's really great because it tells either the person who's reading your solution or yourself, if you're having to go back and check as you're either looking at the problem again or stuck on a part in the middle. Writing a let statement lets you know exactly what you're doing and how you're solving it. Again, you want to be clear. You want to organize your workspace and align everything. We're going to align right down here too. So we've chosen our variable, the x equal 2. Now we're going to put both the original expression, -2 times 6 minus 4x, put equals -12 plus 8x, my simplified expression. Again, however, I don't know this unless I substitute and then fully solve on both sides. So I'm going to put a question mark here. And each one going down, I'm going to put a question mark and try to reach the end. And then I'm either going to have an equal sign, or I'm going to have an equal sign with a slash of it, which means it does not equal. All right, so the next step, after we just listed the original expressions, is to write it in here in parentheses. -2 times 6 minus 4 times 2 equals question mark, notice the line, -12 plus 8 times 2. In this case, remember we're doing order of operations. Usually you want to see you have that on the page, PEMDAS, circle MD, circle AS, multiplication division comes first, whatever goes from left to right, and addition and subtraction comes first, whatever from left to right. In this case, we have multiplication over here and multiplication over here coming first. Because remember, you do each side separately. So we have -2 times 6 minus 8. We're not sure if that equals -12 plus 8 times 2 is 16. Again, over here, you can just do it in parentheses. 6 minus 8, well, it would be -2. Okay, again, because 8 is bigger than 6, so 8 minus 6 is 2, and it's a smaller number minus a bigger number, so it has to be negative. -2 times -2. Does this equal what -12 plus 16? Oh, that's going to be 4. Does -2 times -2 equal 4? Oh, yeah. 4 does equal 4. So like I said above, now I get rid of my question mark. I have just an equal sign, and I put a check. Literally, with the check, you got to put a check if it's right. If it doesn't work, you put a slash, you put an X, and then you have to go back and see what did you do wrong, because you did something wrong. And I wouldn't ever, if you do your check and you find that you got something wrong, I wouldn't erase your solution in your check unless you have 0 space. If you have enough space to do a different solution in check, then just do it in the other space. Because I'll appreciate that you had the perseverance and the integrity to go and do it twice. I'll might see if I start avoiding bonus points for that. But B, it'll really make sure that maybe when you're doing the check, you made a mistake and the original solution was actually correct, and then you have to backtrack a second time. It can be, you can make mistakes in kind of any part, so you never really want to erase any work that you do. Just maybe cross it out, or like put a box around it and put an X next to the box, some way that you know that you think that's wrong, and solve it again next to it in the space that you have. All right, so we've gone over the notes. That's all the notes for today. Again, please make sure you upload your notes to Scholar Notebook. I saw a lot of the girls upload notes. I don't know if I got notes from anyone. Maybe Brian, but I barely got notes from any of the boys. Please make sure you guys are all uploading those notes. It's really necessary that you guys are actually writing the notes at home and uploading them. Remember, the reason why is because every time we write, it's another layer helping us memorize. When we hear something out loud, that's one layer helping us memorize. When we read it, when you read it on a page, when you read how I write it, another layer helping you memorize it. When you write it, that's another layer helping you memorize it. Each one of these layers make that memory stronger and stronger. So a lot of times, if you actually take the notes, you won't even have to study that much because you'll be able to think back to what did I do in the notes. Of course, you'll have the notes there as well to go back and check. I just always, please make sure you write the notes. Please make sure you guys are uploading it. By this Monday, I need all the notes for this week uploaded. I'm being a little nicer with this week because I know it's the first week of me really checking notes since the first since stage zero. Remember, stage zero, everyone was uploading really good notes. In stage one, everybody who was remote, I know Mrs. Fedeli had you guys uploading notes a lot. I know we were taking notes in person. I know we do take notes in person. Please just upload the pictures. So again, if we want to have a record online of those notes, you can always go back and check that. And you'll have my notes as well, but you want to help memorize it. All right, so I'm going to quickly dash through the I do's, and then you will be free to go do the we do's and the IP. Please make sure again that you guys are open informative, that you've done the review already. You should have that done by now, and that you're doing the readers. That's how I know that you're sticking with us in class. That's how I know that you're completing this work, and that's how I know that you're on track to do really well on the next test. All right. So looking at these I do's, both pretty similar. The first one's asking for an area model. Remember an area model from yesterday? We're just kind of using a rectangle bar. And I like to always draw my arrows anyway, even if I'm not going to use the arrow method. Now we have 1/2 on the left-hand side. We have a number, 2x minus 4. You could make this 2x plus -4. But a lot of times I like to just bring this operation straight down because I know it's going to be subtraction now. It's 1/2 times 2x. Well, 1/2 times 2 is 1 plus 1x, but 1 times x is just x. So this is just x. 1/2 times 4, half of 4 is 2. So our answer is very simply x minus 2. Notice if we did the arrow method, I'm just writing out what I just described. 1/2 times 2x minus 1/2 times 4. 1/2 times 2x is x. 1/2 times 4 is 2x minus 2. It's the same exact thing. All right. Whether you use, I hope my face is not blocking that. Whether you use the area model or the arrow method, and you should feel comfortable now using whichever one is best for you. You can always use kind of either one. Always draw the arrows though. You should get the same answer. Just please make sure that you're being very careful and writing out each step. All right, item number 2. Remember, we said that today's lesson is distributing with rational coefficients. So rational numbers are both positives and negatives, and it's also not just whole numbers, but fractions and decimals. So here we have a negative fraction, kind of a double whammy here. It says expand and simplify. Most of the time, even though the area model keeps things very clear, it can be a little time consuming to draw. I find the arrow method a lot quicker. So I kind of always do the arrow method. Remember, I want to write out multiplication here, especially because I'm distributing a negative. So I have -1/4 times 8x minus, just drop that down, -1/4, parentheses because it's following operation, times 4 minus 3x. Order of operations, PEMDAS, circle MD, circle AS. If you're solving these, well, actually, whether you're solving these in a notebook or on in the packet, I expect that each page has PEMDAS on it with MD and AS circled. So that should be a prerequisite. Notice up here, I didn't really need to do it, so I didn't really need to worry about it. But something like this, where we have at least 3 terms, we can distribute and then do something else. You need to have PEMDAS right now because it will really help you keep things clear. All right, let's go through. PEMDAS tells me I don't have anything in parentheses. I mean, these are parentheses, but there's no addition or subtraction in the middle. So there's nothing I can do with them yet. I don't have any exponents. I do have multiplication. That's what these parentheses mean, multiplication. Negative 1/4 times 8x. Well, I know that 1/4 times 8 is 8/4, and that's the same as 8 divided by 4, or 2. So this would be, and negative times positive is a negative 2x. All right, again, negative 1/4 times 4. Well, that's going to be 4/4, which would just be 1. So subtracting the negative times a positive is negative, negative 1 minus 3x. Before you identify like terms here, and you do your circles and boxes, and you should do your circles and boxes, we want to, again, immediately get rid of subtracting negative the same as a positive. Double negative is double positive. So now I have negative 2x plus 1 minus 3x, circle, negative 2x, circle, negative 3x, box the plus 1. Again, put like terms next to each other. Negative 2x minus 3x plus 1. Negative 2x minus 3x. If I want negative 2 and I'm subtracting 3, I'm going left on the number line. So that's getting farther from 0. So that's going to be a bigger negative, negative 5. Negative 5x plus 1. So we're done here with negative 5x plus 1. That's a great answer. You can't combine 5x and 1. They're not like terms. This one has a variable. This one doesn't. However, I just want to point out that you can almost always rewrite terms like this in a couple of different ways. You have this negative 5x plus 1. The commutative property tells us we can add in any order. So you can switch them around, make it 1 plus negative 5x, and that would also work. You could also, again, subtracting any number is the same as adding its opposite. Well, if we're working backwards from that, adding a negative, that's the same as just subtracting a positive. So this is also the same as 1 minus 5x. Really just kind of getting rid of that plus sign. And that is also correct. Any of these would be acceptable. Normally, this is just extra work, so you don't need to get it for something like this. But know that it's possible. Know that these are all equal. But that's it. Please let me know if you have any questions. Please make sure that you're showing this workout. Again, PEMDAS, arrows, boxes and circles, lining things up. A lot of the work has been beautiful. I did want to say before, when we were uploading notes, a lot of the notes that I saw, again, it was a lot of the girls were like Jaleisha, Liani, Johanna, Julissa. I don't want to leave people out. I think Sophia had some awesome notes. Bree had some awesome notes. Who else? A bunch of you guys had really awesome notes. I'm thinking I might start giving prizes or collecting some kind of like, Mrs. Spez box, something like that, for having the work shown, for having great notes, for getting everything right in an IP, a couple of things like that. So if you guys want to do that and possibly earn some gift cards, it's kind of what I'm leaning towards, probably gift cards and maybe candy or stuff, but it's probably kind of impossible for remote people. So we'll see. But I'd be happy to do that for you guys. Because please make sure that you are again showing the work, uploading the notes, doing everything you need to do. It's been looking really great so far. It's been improving every day. homework completion was way up today. So just let me know if you guys have any questions. Otherwise, have a great rest of your day. Good luck with the Wii U's. See you guys in a little bit.